Let's solve this equation. The square root of the quantity x plus 1 is equal to 5 minus x. Here we have a radical, so let's begin by squaring both sides of this equation to eliminate that radical. The square root of the quantity x plus 1 squared is equal to x plus 1. And on the right, we need to now multiply 5 minus x times itself. Don't forget to FOIL this out. In fact, a good next step to write down is this: 5 minus x times 5 minus x. So you can see that we're going to need to FOIL this. 5 times 5 is 25. Our outer product and inner products are both negative 5x, which combine to a negative 10x. Negative x times negative x is a positive x squared. At this point, our equation has turned itself into a quadratic equation. So let's put this quadratic equation in standard form by getting everything on one side set to 0 on the other. I'm going to, on the right-hand side, write that x squared term first, and then the x term next. And as we subtract x from both sides, a negative x and a negative 10x is a negative 11x. Subtracting 1 from both sides, 25 minus that 1 yields 24 and leaves a 0 on the left. Now we have this in a nice standard form. Let's try to solve it by factoring. This fits a nice trinomial format. If it factors, we know it's going to factor into two binomials. Our leading coefficients, or our leading terms, must be x and x to produce x squared. Now we simply need to find factors of 24 that sum to negative 11, and those are a negative 8 and negative 3. The zero factor property then says if we multiply two things together to get 0, then one or the other is 0, or both. So we set x minus 8 equal to 0. We set x minus 3 equal to 0 as well. So our possible solutions here are x equal 8 and x equal 3. Let's be sure to check both of these solutions in the original equation. Our original equation, again, is the square root of x plus 1 is equal to 5 minus x. Let's check the possible solution x equal 8. By substituting it into that equation, the square root of 8 plus 1 is that indeed equal to 5 minus 8. In other words, is the square root of 9 equal to negative 3? Here this is asking for the principal square root, the positive root, which is 3. And we can see that this is a false statement. Therefore, 8 is not a solution to this equation. It does not work. Next, let's check x equal 3. Plugging it into the original equation, this becomes the square root of 3 plus 1. Is that equal to 5 minus 3? In other words, is the square root of 4 equal to 2? Yes, it is. This is a true statement. X equal 3 is indeed a solution to this equation. Let's go ahead then and say that the solution set is the value of 3.